All right, so plugging in here, negative x and square it turns into positive x squared times negative 5 stayed negative 5x squared. So that one didn't change. Well, let's go ahead and finish it off. 6 times negative x would be negative 6x, right? So from there, we see, okay, this changed signs, but the middle piece did not change signs. So is this odd? No, because everybody didn't change signs. So this would be a neither. It was almost odd, but it was not. Okay, it's a neither situation. Notice how we've got, what's the exponent on this piece? It's odd, it's 3. This is an even exponent, this is an odd. We got a mix of odd and even exponents on the variables. There's a neither. Okay, so that's kind of the shortcut that you can think about with that. If we had something like this, g of x equals negative 8x to the third minus 5x. This video may not be going to work here. It's still recording. Okay. Very good. So far. Just have to put them together. All right. So, again, testing for odd, even, or neither. Plug in a negative x into the function. Negative 8 times negative x to the third minus 5 times negative x. Right? What does the first piece turn into? Positive 8x to the third. Negative 5 times negative x would be positive 5x. Is that the opposite of the original? Everybody changed signs. So this one would be odd. Because everything changed signs. So to be odd, everybody's got to change signs. The shortcut, what kind of exponents are on these variables? Odd. Every term has an odd exponent on the variable. So it's an odd function. Okay. So that's kind of the shortcut you can take. X squared plus 7x plus 12. If I do the test and plug in negative x, it's going to be x squared, so nothing changed there. But that's minus 7x, and that's plus 12. Is that odd, even, or neither? Neither. Because everybody didn't stay the same, everybody didn't change. Okay? If everybody stays the same, it's even. Everybody changes signs, it's odd. Here, the shortcut, you got a mix of odd and even exponents. Then you got a guy that doesn't even have an exponent, right? It doesn't even have a variable on it. So when there's a constant term there, you know that it's got to either be even or neither. It can't be odd. If it's got a constant term in it. That's kind of a shortcut that you can take. All right. So if you got an equation, the test is plug in negative x. There are some shortcuts, but the test is to plug in negative x. Graphically, to recognize it graphically, there's some things that we look at. What does the term symmetry mean? Say it again. Same on either side, okay? So if there's symmetry, that means you could fold it and it match up. It's the same on both sides, right? So if there's symmetry with respect to the y-axis, what that implies is that it's an even function. Okay. And what I mean by that is you fold it, your symmetry line is the y-axis. You picture folding the graph on the y-axis like this, the vertical axis, and it should match up. If with respect to, that's what that means. You know, that you're folding it with respect to the y-axis means you're folding it on the y-axis. Is what that means. Okay. If there's symmetry with respect to the origin, what's the origin? 0, 0. Okay. And it's odd. So it's hard to kind of visualize this. Graphically, it's sometimes hard to visualize what's going on. But with respect to the origin, I think the best way to visualize that is that it's folding both on the y-axis and then folding across the x-axis. Okay? And if it matches up then, that's an odd function. Okay? And really what's happening is you're taking the opposite of x and the opposite of y, and it matches up. So like if you had the point 3, 2 is part of the graph, is the point -3, -2 part of the graph? Is reflecting it across the origin. Okay. Is what's going on. And then if it's not symmetric to either of those, then it's neither graphically. Let's look at some examples. I think you'll see what I'm talking about. Do a nice parabola to start off with. Just sketching some graphs. You don't have to have particular points on it here. Just a coordinate plane. What would that one look like it is? Even. So if we folded this on the y-axis, this side would flip over and match up to that side. That's what I'm intending to draw here. Hard to draw perfectly, but that's what I'm trying to get at you there. That this would be even. Because it's symmetric about the y with respect to the y-axis. Okay. Yes, ma'am. Not necessarily. It is not a particular shape that it always has. Let's look at this one. I think that one's odd, right? Because if you visualize flipping it across that y-axis so that this side gets over here, and then flip it down, they would match up. Okay, so it's hard to visualize, or the odd ones are harder to visualize. Even is easy because we can visualize one fold. Two folds are harder to visualize. But this would be an odd one. Another clue that it's an odd one graphically is that it goes through the origin. Like the graph actually goes through the origin. That's a lot of times a major clue that it's an odd function, that it goes through the origin. Let's see. G. Sketch another one here. What about that one? Neither? Neither, whichever one you want to call it. Same word, I guess. All right, because if we fold it across the y-axis, it definitely doesn't match up, so it's not even. If we fold it across the y-axis and then across the x-axis, we get this little jumbled mess that doesn't match up. So this would be a neither. Pretty easy to do though. All right. All right. So odd, even, neither testing with functions. They give you the equation or the graph. We can recognize that hopefully with that. Let's go to the next thing in this section. Let's talk about some intervals of increasing, decreasing, and constant intervals. I mentioned this in the first section, or the section we were talking about the functions and their graphs and things. So we're going to try to draw a graph here. I'm going to be a little bit more precise with this one, but not just crazy. We'll just get you an X and a Y axis. And the most important part is the points that I mark and then the shape of the graph, when I put it there. So I'm going to change colors here. -6, 0 is that ordered pair. Let's do a -4, 2, -2, excuse me. And then let's go up here to 0, 4, 3, 4, and then 6, -1. All right, so I'm going to draw the graph. I'm going to just use just a curve here, not coming from any particular function, just a kind of random draw here. All right. Now, if something is increasing, and we're talking about intervals deal with X or Y. Which one? We write our answers as intervals. X's. Okay, so it's like the problems on the last section where you had to tell where was f of x greater than 0. You had to tell me that interval from like -3 to 6 or something like that. Okay, so when we're talking about intervals here, we're talking about the x values that are increasing or decreasing on the graph. Okay, not necessarily the x values increasing or decreasing, but the graph increasing or decreasing. So what we want to think about when we think increasing, decreasing, and constant is slope. Okay, even though this isn't a perfectly straight line, we can still think about slope in the same way we've always thought about slope. So if something is increasing and we're reading slope, we always read a graph left to right, just like you would a book, right? So if it's increasing left to right, is it going up and to the right or down and to the right? Up and to the right. So it's going to look something like that. Decreasing would be the opposite of that. Constant is what? Same, flat, right? Okay. So when we're looking for an increasing interval, we're looking for something that's going up and to the right. If we're looking for a decreasing interval, we're looking for something that's going down and to the right. Constant, we're looking for flat. Okay. All right. Now, let's first get the domain of this graph that we've sketched here. It's the domain of that graph. Okay? Brackets or parentheses? Why? Starts and stops on those points, and they're not empty circles. So we are going to include those. That's correct. The brackets is correct. Okay? What would the range of this thing be? -2 is the lowest y value we got. The highest y value, 4. -2 to 4. Brackets or parentheses? Brackets too, because those points are not empty circles, so they're included. So that's why they're going to be brackets on those, okay? Because those points are included. Okay. Now, when we're talking about these intervals, they have to fit within the domain. And when we're talking about the y values changing, the increase, decrease, or constant part, we're looking within the range. Okay, so everything that's happening is within the domain of the graph or within the range. Okay, so you're not thinking about what would happen later on in the graph. You're looking at what's there. Okay, so let's list our increasing, if we have any, our decreasing, if we have any, and our constant intervals, if we have any. It is absolutely okay if you get a graph and it doesn't have any increasing intervals, or it doesn't have a decreasing interval, or a constant interval. They can have, one without the other. Okay, it doesn't necessarily mean you have to have one for everyone. This one does have every one of them because it's the example that I want to show all of that stuff with. Okay, so if we just read this left to right, what's going on when we start here at -6? What's the graph do? It's decreasing until we get where? -4, 2, right? So the interval of decrease goes from where? -6 to -4. And we're going to put parentheses on those intervals, because does it start increasing at -4 or stop decreasing? Which one? We don't know. So we're just going to use, on the intervals of increase and decrease and constant, you're always just going to use parentheses. Don't worry about brackets on those. Okay. Always use parentheses because that's just the place it turns around. Okay. Then what's it doing from -4? Where are we going next? Increasing. So it starts increasing at -4 and increases until we get where? To 0. Yeah, that's right. Because it's increasing from here up, 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 right there, and then it changes directions. Okay. So starting at 0, what's it doing? It's constant until I get to 3. So from 0 to 3. What happens at 3? Starts decreasing until I get where? To 6. So I got another decreasing interval from 3 to 6. We don't know what's happening after that. There may be another piece that starts increasing, maybe a constant piece. We don't know. Doesn't matter. So we've got 2 decreasing intervals and 1 increasing and 1 constant. And that's okay. There's no rule that says you have to have, a certain number of any of those. Okay. You just look at the graph, read it left to right, and get your intervals. Not just incredible hard stuff there. Okay. All right, let's look at maxes and mins. Okay. Maximum. What's a maximum? Highest. Or a minimum. Now, maximum and minimums can be local or absolute. I taught this same stuff last night at YouTube. So use the example I used last night. We were talking about there was a few people that I knew in the class that play music and play guitar, and I said, locally would be like in this room. I said, I think we could probably figure out who is the highest ranking guitar player in this room, right? And that would be locally. But absolutely would be like in the world. And that's a little bit more difficult to do, right? But locally is within a certain area, right? So you think about, I don't know if you've ever, you follow a certain band or something like that, and you want to see when they're playing close to you. And close to you, maybe within 50 miles. Close to me, maybe like within 100 miles. But you've got to set some sort of parameter saying local means between this distance, right? So if it's local, what we're going to be looking at is over a certain interval, okay? We're going to be given an interval to look into. Okay, so from -2 to 5, what's the local maximum? From -2 to 5, what's the local minimum? So you're looking for the highest point for the maximum within that range or that interval. You're looking for that point that's the highest. And if it's the minimum, you're looking for the lowest point, but they're going to give you an interval to look into. So you're going to say, okay, they said look between -2 and 5. So I'm only going to look at that part of the graph for locals. For absolute, that's going to be across the entire domain. Okay, so local is going to be part of the domain. Absolute is going to be across the entire domain. Okay, so local is small window, absolute, the whole picture, the whole domain of the thing. Okay, let me find my textbook here. Let's look at page 234 on your book, in your book. You got your book handy. If you don't have it handy, just look on with your neighbor. We're just going to glance at a picture here. Page 234. And let's look at figure A. So that's the first one on the left at the top of that page. So I'm looking at this page. I'm looking at that one up there right at the top. One on the left. That's the one I'm looking at. Okay. All right. So I want to find the local max over 2, 4. So this would be example something. This was example H. This would be example I. Okay. So I'm telling you the interval that we're looking between is from 2 to 4. I noticed that the x-axis for that picture doesn't have a 2 or 4 marked on it, but we can reasonably estimate where that's at. What would the local maximum be on that graph? The y value would be 6. That's exactly right. Okay. Local max would be at 3, 6, the ordered pair. So this is an interval. This is a point. That is a very confusing thing for a lot of students, is that looks exactly the same. But you got to know what you're talking about when you're looking at stuff. Okay. Let's look at same picture. Let's get a local min over, change the interval from 2 to 5. Okay. So we're looking for the lowest point between the x values of 2 and the x value of 5. 4, 4. So at the point 4, 4. Now, if we change and say, let's get the absolute max and min. Same picture. Absolute means you're looking at over in what part of the graph? The entire domain. What is the entire domain of the graph on figure A? 0 to 5. Are those points included? Brackets or not? Yes. Brackets on those because they're filled in dots, right? Not open circles. Okay. So what would be the absolute max for the entire domain? 36. At the point 36. Happens to be the same one as our interval for the local max had, but that happens. It just depends on what interval you get. At 36. Okay. Where would the absolute min be? 0, 1. Yeah, the lowest point on the graph happens to be the first point on the graph, 0, 1. Okay, so absolutes across the entire domain. Local, they're giving you a window to look into. Know the difference in those. Okay. Now, where we can get into a little more technology stuff. Let me go ahead and open up my graphing calculator here. Let it be loading while we write this problem down. AKL using a graphing utility on the local max and local min over -2 to +2 for f of x equals 3x to the third minus 7x plus 1. Okay, so they don't give me a graph to look at. Okay, but they tell me to use a graphing utility to find the local max and the min over this interval. Okay, so I'm going to use my graphing calculator to graph this function. Okay, it's a cubic, so we should have some sort of idea about what it looks like. We know it's going to look something like that, right? From Algebra 2, you graphed cubics or looked at higher degree polynomials. We know it looks something like that. We're just going to use the calculator to get us a graph, and then we're actually going to use the graphing utility to help us find that max and min and get a very good estimate for that. It's going to be a rounded value, but that's okay. So I'm going to y equals. I'll clear out some stuff here. All right, and I'm just going to type in that equation. 3x to the third minus 7x plus 1. And hit graph. All right, does look like kind of similar to what it is. Yes, ma'am. Hit zoom 6, and that should get you to the window that I'm in. If your graph is adjusted in some way that's not looking like this, if you'll hit zoom and then the number 6, it'll set it to the standard window, which is 10 by 10. Okay, so if your graph ever gets messed up, zoom 6 will set it back to the default window. Okay, has everybody got that graph drawn? Having trouble? The caret symbol right here underneath the clear, so you're going to type 3x and then hit the caret symbol and got it? Okay. Everybody catch it. All right, so now we're going to use the calculator to look inside of that interval and find a max or a min. Okay, and the way that works is it's got a menu option that'll let you do this, and this is legal on ACT, on quizzes and tests, and all that stuff. So what you want to do is hit second trace. Okay, and it should take you to the calculate menu. Second trace. Trace is right beside the graph button. Okay. It's highlighted in red on my keypad there. Everybody there? Okay. Now, look at options 3 and 4. Minimum and maximum. That's what we're looking for. We want to find the maximum first. All right, so we're going to do number 4 first. It asks for a left bound. The left bound is the start of your interval. What's the first number in our interval? -2. That's the one we got from the... So -2 and hit enter. It asks for the right bound. The right bound is the other end of your interval. It's +2. All right. Notice mine puts the little lines here. Resolution on the software may be a little bit better. If you've got one of the color ones, it may put the lines there. I don't know for sure. I hadn't used the handheld color one enough to know. But all of them will put those arrows there. No matter which version you've got, the arrows should be there. Is everybody with us? I don't want to run off and leave anybody. Okay, now what that's saying is, okay, that's the boundaries. It's going to look inside of there. It asks you to guess. It actually is important that you do guess, because if you just leave it wherever it's at, it can sometimes get a little off. All right, so right now the cursor is over here at +2, 11. So I'm gonna press to the left and see how that little spider comes jumping down there. I call it a spider. It's only got 4 legs. It's half a spider comes jumping down there, and then I'm looking for a maximum. So I'm just going to press to the left until I get close to that maximum where I know it's at. I can recognize it visually that it should be somewhere around right there. By just moving the cursor, I got to negative 9.09 repeating, right? And then 5.1. That's really close, but it's not as close as it's going to be when I hit enter. So I'm going to hit enter. And it calculates the maximum, finds that exact point to be negative 0.88 and 5.12, or 2 decimal places. Okay. So max negative 0.88, 5.12. All right. Now, let's find the minimum. So what are we pressing to get to the menu that lets us pick minimum? Second trace. And then it's option number 3. You can either press the number 3 or arrow down and hit enter. It asks for that interval again. We'll finish this tomorrow. Okay.